Hello and welcome to this series of briefings for the UK NPPL 3-axis Microlight syllabus, Bitesize. Each one, in 4 or 5 minutes, should help you prepare or recap elements for each exercise. This briefing covers how to maintain level flight in exercise 6. Maintaining level means maintaining a constant altitude, height or flight level. We use the horizon as a visual reference, along with the following instruments: the altimeter, the vertical speed indicator, or VSI for short, and the engine RPM gauge. We'll also add the airspeed indicator, or ASI for short, just for good measure. When the aircraft is trimmed for a speed, then there will be a power setting that means that the aircraft neither climbs or descends. This power setting will vary slightly from day to day based on the density, altitude and the weight of the aircraft. A power setting of 4,200 RPM typically gives an airspeed of 65 to 70 knots in level flight for an Icarus C-42. Looking at the horizon ahead, we use the control column to hold the nose of the aircraft steady relative to the horizon. We then need to increase or reduce power so that the altimeter needles are steady at the desired altitude and the VSI needle is steady on 0. In this example, we will maintain 2,500 feet. Too much power and the aircraft will pitch up and climb. The VSI needle will point upwards, indicating a rate of climb, and the altimeter needles will move clockwise as we increase in altitude. Not enough power, and the aircraft will pitch down and descend. The VSI needle will point down, indicating a rate of descent, and the altimeter needles will sweep anti-clockwise as we decrease in altitude. What we need to do is hold the aircraft attitude steady relative to the horizon and find the sweet spot where the power is just right and the aircraft is neither climbing or descending. This will be shown by the VSI reading 0 and the altimeter hands being steady. Bear in mind that because of how the VSI works, it has a delay of several seconds when transitioning from a climb or descent to level flight and vice versa. Over time, you will learn to recognize the different attitudes and engine sound for certain power settings required to maintain level flight at various speeds. Sometimes we encounter some light turbulence which upsets the aircraft's attitude. When this happens, use the control column to hold the nose of the aircraft in the desired position relative to the horizon. At other times, we might notice that despite the power and attitude being set correctly, the altimeter and the VSI show that we are climbing or descending. This is because we are flying through pockets of rising or falling air. This could be due to thermals or updrafts and downdrafts in the vicinity of mountains, for example. To correct for a climbing trend, we pitch the aircraft down slightly and reduce power slightly to maintain the desired altitude. When this attitude and power setting no longer maintain level, we have passed through the rising air and we can reset our original attitude and power setting. If the aircraft is descending according to the altimeter and VSI, despite the correct attitude and power, then we are passing through sinking air. To correct for this trend, we increase power and pitch the aircraft up slightly to maintain level. When we begin to climb above the desired level, we reset the original pitch and power settings to maintain our desired level. As ever, any increase in power makes the aircraft want to turn left, which we need to use right rudder and aileron to counter in order to maintain our straight track. And a reduction in power means we need to use left rudder and aileron to counter the tendency to turn right.